friends, this is Jhunjhunwala. Welcome back. Our topic for today is cubes and cube roots. We have already studied about exponents, we have studied about squares and square root. Now, what is this cube and what is the meaning of cube root? Today we'll discuss about it and we will learn about the various properties of cubes as well as the application of cubes and cube roots. Where actually do we use cubes and cube roots in real life? Okay, now what is the meaning of this 2 to the power 3? You have studied in exponents. Now there's a special name for this power 3 and it is called cube. 2 cube means 2 into 2 into 2, which is equal to 8. Minus 2 whole cube means minus 2 into minus 2 into minus 2, which is minus 8. So we learned that the cube of 2 is 8, cube of minus 2 is minus 8. The cube of a positive number is positive, whereas the cube of a negative number is negative. Now 8 is the cube of 2. We can also say that 2 is the cube root of 8. Minus 2 is the cube root of minus 8. For cube we use power 3 and for cube root we use power 1 by 3. So if x cube is the cube of x, what will be the cube root of x cube? Cube root of x cube will be x cube to the power 1 by 3. This radical sign with a 3 over here means cube root. Cube root meaning power 1 by 3. So, if x cube is raised to the power 1 by 3, we are getting x. X cube is the cube of x and the cube root of x cube is x. Can you tell me what is the cube of 10? 10 cube means 10 into 10 into 10. So we get 1000. Here there was 1 0, but here there are 3 zeros. So when we cube a number, the number of zeros get tripled if the number is ending with a 0. What will be 20 cube? Now 2 cube is 8, and since the number is ending with a 0, there will be 3 zeros in the cube of 20. Okay, now if you have to cube a fraction, what will you do? If you have to cube a fraction, you will cube the numerator and the denominator separately. What is the cube of 2? Cube of 2 is 8. What is the cube of 3? 3 into 3 into 3? 27. So we are getting 8 by 27. Again you can see that the cube of a proper fraction is less than the fraction itself. Let's take a decimal number. What is the cube of 0.2? 0.2 into 0.2 into 0.2. So after decimal we should be having 3 digits. 2 cube is 8. Again we can see that the cube of a decimal number is less than the given number. Let's discuss some properties of cubes of the first few natural numbers. What is the cube of 1? 1 cube is 1 into 1 into 1, which is 1. 2 cube is 8. 3 cube is 27. 4 cube is 64. 5 cube is 125. 6 cube 216, and so on. Now you can see that 1, 3, 5, which are odd numbers, their cubes are also odd, and for even numbers you can see that their cubes are also even. So this is a very important property we have learnt, and we have seen that cube of a positive number is positive, cube of a negative number is negative. Let's find the cube root of 0.027. Can you do it mentally? Is 27 a perfect cube? Is 27 the cube of a natural number? Yes, it is. 27 is the cube of 3. So let's do one thing. We'll convert this decimal into a fraction. Since after the decimal 3 digits are there are 3 zeros in the denominator. Now, what is the cube root of 27? 3. What is the cube root of 1000? 10. So, we are getting 3 by 10, which is 0.3. Now, this was a very, very small number, 27. It was the cube of 3. All of you understood that. But what to do if you have a bigger number? Then how will you find the cube root? We will be using the prime factorization method today to find the cube root of a natural number which is a little bigger than 27. Okay, if you have to find the cube root of 343, let's use the prime factorization method. 343, is it divisible by 3? No, it's not divisible by 3, it's not divisible by 2, it's not divisible by 5. It is divisible by 7. 7 5s are 35, we cannot write, so 7 4s are 28, remainder 6, we are getting a 63. 7 9s are 63, 7 7s are 49, 7 1s are 7. So, cube root of 343 is cube root of 7 into 7 into 7. Do you remember what we were doing when we were finding square root? When we were finding square root, we were pairing the prime factors which were same. But since this is cube root, instead of making pairs, we are going to make groups of 3 when the prime factor is repeated. So 7 is repeated 3 times, and this will form one group of 7, and when we find the cube root, from this one group of 7, a 7 comes out. So cube root of 343 is 7. Now let's find the cube root of 1728. Is it a perfect cube? Is this the cube of a natural number? Let's check. 1728 is divisible by 2. Let's divide. Again, 864 is divisible by 2. Again, 432 is divisible by 2. Two fives are 10, two fours are 8. Again, we can divide by 2 and we get 27. This 27 is divisible by 3. 3 nines are 27. 3 threes are 9 and 3 ones are 3. So we are getting 1, 2, 3, 4, 5, 6. 6 twos and 3 threes. When you get many prime factors which are same, instead of writing like this, you may write like this. When you were writing like this, you were making groups of 3. And when you write like this, you will divide each power by 3 to find the cube root. We are finding cube root, so don't forget, we must put this 3 for the radical sign. So, since we have written in exponent form, to find the cube root, each exponent has to be divided by 3. 6 divided by 3 is 2 and 3 divided by 3 is 1. So, we are getting 2 2s are 4, 4 3s are 12. Let's check whether 648 is a perfect cube, whether it is the cube of a natural number. Six 48 is divisible by 2. 2 3s are 6, 2 2s are 4 and 2 4s are 8. 2 1s are 2, 2 6 are 12, 2 2s are 4, 2 8s are 16 and we get 2 1s are 2. Now this 81 is divisible by 3. 3 2s are 6 and 3 7s are 21. 3 9s are 27, 3 3s are 9 and 3 1s are 3. So we are getting cube root of 648 equal to cube root of, there are 3 2s and there are 4 3s. The 3 2s make a group and these 3 3s make another group. Now since there is a group over here, it can come out of the cube root sign. Again, since there is a group over here, it can come out of the cube root sign. For this group, we have a 2 which has come out, and for this group, we have a 3 which has come out. Now what about this 3? Poor thing, it could not come out of the cube root sign. So we are getting 6 into cube root of 3. We can say that 648 is not a perfect cube. Okay, can you tell me by which number should 648 be divided so that it becomes a perfect cube? If this extra 3 would not have been here, then 648 would have become a perfect cube. So if we divide 648 by 3, we get a perfect cube. Okay, tell me, by which number should we multiply 648 so that it becomes a perfect cube? I'm talking about the least possible number by which we should multiply 648 so that it becomes a perfect cube. Here there is a 1 3 which is alone. If there were 2 more 3's, then it would have formed a group and the group of 3 would have come out. So we need 2 more 3's, meaning 3 into 3, 9. So 648 should be multiplied by 9 to make it a perfect cube. Okay, tell me, is 32 a perfect cube? No. Is 54 a perfect cube? No. Then how should we do such a calculation? Let's find out if there is a possible way. Okay, what if I combine both the calculations? Since we have cube root 3 here also and here also, let's combine both under the same radical sign and we get 32 into 54. Cube root of 32 into 54. Let's prime factorize 32 and let's prime factorize 54. Let's prime factorize 32. 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. Let's prime factorize 54, 2 27, 3 9, 3 3s, 3 1s. So we have got 1, 2, 3, 4, 5 2s over here. And here we have got 1, 2 and 1, 2, 3. 3 3s. So if we apply laws of exponents, 2 to the power 5 into 2 to the power 1 is 2 to the power 6. Since I have written in exponential form, to find the cube root, I will divide the exponent by 3. So when I divide 6 by 3, I get 2. When I divide 3 by 3, I get 1. 2 2s are 4, 4 3s are 12. So, though 32 is not a perfect cube, though 54 is not a perfect cube, if we multiply them and we find the combined cube root, we are getting 12. Okay, now let's do some sums where we find the application of cubes and cube roots. Suppose the edge of a room which is cubical in shape is 7 meters. If the edge, one edge, length, breadth or height of a cubical room is 7 meters, then what will be the volume of the room? Volume of the room will be side cube 7 cube, which is 343 cubic meters. Okay, suppose I give you the edge of the volume of a room is this much. If the volume of a room, or say if the volume of a cubicle box, okay, if the volume of a cubicle box is this, can you find an edge of the box? Since the volume is a cube and it is equal to this, if the volume is equal to this, edge will be cube root of this. So when we convert this into improper fraction, 1000 plus 331 gives us 1331. You can calculate and find out that the cube root of 1331 is 11, and you can see there are 3 zeros, and cube root of 1000 is 10. So we are getting 1.1. So each edge of the cube or cubicle box is 1.1 unit. I hope students you have understood this lesson, and if you have any doubts you are free to use the comment box and get back to me. If you have liked the lesson, please do press the like button and subscribe to my channel.